First and foremost, we go through the introduction of intestinal arginine. Intestinal arginine is an amino acid that is naturally found in the human body and is also obtained from the diet. When it is consumed through the diet, it is absorbed in the intestine and enter the bloodstream, where it can be utilized by various tissue and organ in the body. Intestinal arginine is classified as a semi-essential or conditionally essential amino acid, meaning that under normal circumstances, the body can produce enough of it, but in certain situations such as illness or stress, the body may not be able to produce sufficient amount and it must be obtained from diet. Intestinal arginine is found in variety of food including meat, poultry, fish, dairy products, nuts, seed and legumes. It also involved in various physiological processes such as serve as precursor for the synthesis of nitric oxide and important for protein synthesis, wound healing and hormone secretion. It is also available as a dietary supplement and is often used to support cardiovascular health, athletic performance and overall well-being.
Next, we move on to function of arginine within the intestinal. The first one is arginine as a nitric oxide production. Arginine is a precursor to nitric oxide, a molecule that plays a crucial role in regulating blood flow, immune function, and neurotransmission. In the intestine, nitric oxide helps to relax and dilate blood vessels, which can improve blood flow and nutrient absorption. Arginine also plays a role as a gut barrier function. Arginine has been shown to support the integrity of the intestinal barrier. It helps maintain the structural integrity of the intestinal lining, which is important for preventing the passage of harmful substances from the gut into the bloodstream.
Metabolic pathway. Small intestine is major source of citrulline for arginine synthesis by kidney. Citrulline taken up by kidney for arginine production. Beside kidney, citrulline also readily to convert to arginine by nearly all types of cell. Inside the cell, citrulline is converted to arginine via argininosuccinate synthase and lyase, and it is the only pathway for citrulline utilization. Inside the cell, there are multiple pathways for arginine degradation that are initiated by arginase, nitric oxide synthase (NOS), arginine glycine aminotransferase (AGAT), and arginine decarboxylase (ADC). First, liver contains abundance of arginase. Through hepatic urea cycle, arginine is hydrolyzed to urea and ornithine by arginase. Ornithine may be decarboxylated to polyamines or transaminated to form prolines. Polyamine is functioning in cell signaling, growth, and proliferation. Next, by NOS. NOS has three isoenzymes, NOS1, NOS2, and NOS3. All NOS enzymes metabolize arginine to form nitric oxide that involve in process associated with vasodilation and cytotoxic mechanism and will form citrulline as byproduct. Next, in kidney, arginine react with glycine to produce guanidinoacetate that are catalyzed by AGAT. Guanidinoacetate then released into blood and travel to liver where it will convert to creatine by methylation. Arginine also can react with lysine to produce homoarginine and ornithine. Homoarginine is speculated to inhibit the activity of arginase and NOS. Next, by arginine decarboxylase, arginine is decarboxylated to form admatine in brain and central nervous system. Admatine is involved in the neuromodulatory function. Here is the summary of the pathway.
Next, the organ-specific metabolism of intestinal arginine. Arginine metabolism is mainly involved in the production of nitric oxide. Arginine is metabolized by the enzyme nitric oxide synthase to produce nitric oxide. Nitric oxide plays an important role in regulating intestinal blood flow, mucosal integrity, and immune function of the body. Arginine metabolism in the intestine is also involved in the synthesis of polyamine, which are important for cell growth and repair. The conclusion, metabolism of arginine in the intestine plays a vital role in maintaining intestinal health and function. It is also influenced by various factors such as diet, gut microbiota, and pathological conditions which can impact overall intestinal health.